Good morning to everyone. I am Sister Pushpa, Assistant Professor, Department of Mathematics, Auxilium College of Arts and Science for Women, Regunathapuram. Today we are going to see some of the important definitions in graph theory. Now we'll see the definition of graph. A graph is a collection of vertices and edges. It is denoted by G equal to V, E, where V equal to V of G is a set of vertices, E equal to E of G is a set of edges. This is an example for the graph. Example, V of G equal to, there are 4 vertices are there, V1, V2, V3 and V4. E of G equal to E1, E2, E3 and E4. Definition of self-loop. A self-loop is an edge that connects a vertex to itself. Example, this edge is called self-loop. Parallel edges. If more than one edge associated with a given pair of vertices are called parallel edges. If we take E4 and E5, these 2 edges are called parallel edges because these 2 edges connected with a pair of vertices V1 and V3. Simple graph. A graph that has neither self-loop nor parallel edges is called a simple graph. I have given 2 examples. The first example is not a simple graph. The second example is a simple graph. Definition of isolated vertex. A vertex without an incident edges is called an isolated vertex. So if we take vertex V1, there isn't any edges or incident in this vertex V1. That's why we name this V1 as a isolated vertex. Degree of the vertex. The degree of a vertex is the number of edges incident on V. It is denoted by D of V. So for example, if we take this diagram, for the degree D of A equal to 4, D of B equal to the degree 3, the vertex D of C equal to degree 4, D of D equal to 6, D of E equal to 4, D of F equal to 4, D of G equal to 3. Null graph. Degree of all vertices in the null graph is 0. So if we take all the vertices, for all the vertices the degree is 0. That's why we name this graph as a null graph. The definition of pendant vertex. A vertex whose degree in a graph is 1 is called a pendant vertex. The vertex A and C are pendant vertex because their degree is 1. The definition of regular graph. A graph in which degree of all the vertices is same is called as a regular graph. Here there are 4 diagrams I have given. So for all the degrees in each vertices are same. Each graph if we take the degrees are same. That's why we name all this graph as a regular graph. The definition of complete graph. A simple graph with n vertices is called complete graph if the degree of each vertex is n minus 1. That is, one vertex is attached with n minus 1 edges. A complete graph is also called full graph. The definition of subgraph. Let G and H be 2 graphs with vertex sets V of H, V of G and edge set E of H and E of G respectively such that V of H is connected in V of G and E of H is contained in E of G, then we call H as a subgraph of G. The definition of bipartite graph. A graph is a bipartite if the vertices V can be partitioned into 2 disjoint sets V1 and V2 such that every edge connects a vertex in V1 to a vertex in V2. That is no edge within V1 and no edge within V2. So look at this diagram. We can see that no edges are connected within V1 and V2. Next, the definition of complete bipartite graph. A complete bipartite graph Km, N is a graph that has its vertex set partitioned into two subsets V1 of size M and V2 of size N, such that there is an edge from every vertex in V1 to every vertex in V2. Example, here there are four complete bipartite graph here I have given. First graph K2, 3, there are two vertices and 3. So we can name this graph K2, 3, the second graph K3, 3, the third graph K3, 5, the fourth graph K2, 6. The definition of label graphs. Labels are just the names we give for vertices and edges are called labeled. Here I have given four graphs. The first one unlabeled graph. The second one only edge label graph, the fourth one vertex label graph, the fourth graph label graph. The definition of finite and infinite graphs. Finite graph, a graph with finite number of vertices and edges is called a finite graph. This graph is an example for finite graph. The definition of infinite graph, a graph with infinite number of vertices and edges is called an infinite graph. These two graphs are example for the infinite graph. Next you will see the definition of isomorphism of graphs. A simple graphs G1 equal to V1, E1 and G2 equal to V2, E2 are isomorphic if there is a bisection, that is an one-to-one function on onto function f from V1 to V2 with the property that A and B are adjacent in G1 if only if f of A and f of B are adjacent in G2 for all A and B in V1. Such a function f is called an isomorphism. For example, they must have the same number of vertices, the same number of edges and the same degree of the vertices. This is an example for isomorphism graph. There are two graphs, so same number of vertices and same number of edges are there in these two graphs and same number of degrees. This way we call this graph as a isomorphism of the graph. Thank you.